let me just try and recap where we left off before the break. Now, so like I was saying to you, if you have two option payoff curves, I'm going to call it X and Y. Okay, and when you go from X to Y, then what happens is that now here what I have written here is a put option. Okay, for the part where it's in the money. So that will be this part here, okay? When you migrate from X to Y, when the curve is slowly sinking, then the delta of an in-the-money option it will rise because it's getting steeper from here to here. Now, I have said this many times, and also the gamma will also go up because the closer you are to the baseline, the more convex. Now, if it's out of the money, then it's a little bit different. Okay, so your delta of out of the money will go down, or at least I should say the absolute value, okay, because your put deltas are always negative. So it might go from negative 46 to negative 42, okay, and then your gamma also increases regardless, okay. Now, what I do want to say in addition is, what do I mean when your curve goes from X to Y? Okay, now there can be two scenarios. One is time decay, of course, when time passes. Okay. Well, two is when you simply reprice your options with a lower volatility, with a lower sigma, with your own estimate of sigma. Okay. Now that, of course, was exactly what the last question was asking you. The last question of set one. Okay. So I just want to make that point quite clear. And then whether your curve is sinking because of time decay, or whether your curve was sinking or rising because you are repricing with a lower sigma, okay, you still get these effects here. You still get these effects here that I just described to you. Okay. Now this is now I'm recording it. This is the second segment. Let me then go to another set of questions. Now this time it will be set number 3. So I'm going to open that up, and now this question is asking, so there are two options here, and they relate to the same stock, and one of them is longer than the other by 30 days, and then the short-term option actually has a higher gamma. Now that part is not surprising because that's how it should be, but the second option also has a substantially higher theta. And what we're asking you to recall here actually are those slides regarding the what we call the forward volatility. I think I told you about that I think 2 sessions ago, when given the volatility of a 60-day option, given the volatility of a 60-day option and the volatility of a 30-day option, I want to draw the 60-day a little different. So this is the 60-day. If this is the 30-day and this is the 60-day, then the 30-day vol in 30 days time is probably somewhere here. Now how do I know that? Because if I take the average of this one and this one, I would get back the one in the middle. Okay, so in other words, this looks like it may be happening here. And in fact, what you can do is, if you recall the formula, the time decay is equal to a half times gamma times sigma s, or sigma square s square is the same thing, okay? Then you can deduce that for option A, now let's just assume that the share price is $1. It doesn't matter, okay? We don't know what the share price is, but you can get rid of that quite easily, okay? So if the share price was $1, then for the first option, you can say that $3.50, the theta, is equal to a half times gamma, which is 20, times sigma square. Now this is sigma for the 30-day option, okay? And you'd find that actually, and that implies that the sigma square for the 30-day is 0.35, okay? So that would be the variance. Now for option B, you can give it the same treatment. For option B, so the theta is 1.5. So you can say this should be equal to a half times the gamma, which is 10, times the variance of the 60-day option. And that implies that the 60-day variance is actually 0.3. Now this is exactly the situation that we find here, okay? Is that for the 30-day, the variance is 35, but the 60-day it's lower. So that implies that the forward variance, if you like, from 30 to 60 days must be somewhere down here, okay? So this is kind of like the average. And one explanation for that, as we talked about, I think in the first or the second session, is that here is when there's no news is expected. So it's just the stock or the company pretty much trying to go about its business on an ordinary boring day. And if in the first period there also was nothing happening, then the first period volatility should be similar. Okay, now why is the first period up there? It's because on a particular day there is going to be some kind of announcement, and for that day there is expected to be a lot of volatility. So as a result, this whole thing gets dragged up to this 35 level here. Okay, so B is actually the right answer. Okay, so I don't want to just tell you, oh, B is the answer. Okay, so I'm taking you through the logic behind that question. Okay, now for question 2, you okay? For question 2,
Sam, can we just compare the gamma theta ratio?
Can you just compare the gamma and theta ratio?
Yeah. Can we do that?
Yes. She's asking, can you just compare the gamma theta ratio? Of course you can. Because if you have theta is a half gamma sigma square s square, the gamma theta ratio, if you take theta divided by gamma, is just a half sigma square s square. So you find that the ratio of one is higher than the other. So there must be something going on. When you take the ratios of these, in fact, S will disappear. You come to the conclusion that there's a significant difference in the sigma parameter. That's your question, right? Yeah, you can do that. Very, very good. Actually, that might be a better way to think about this. Yeah. A lot of the time, I try to explain things by first principle, but if you can think of a better way, feel free to do that. Now, the second question. This one actually is simply an extension of the previous question. The formula that you use, to work out the volatility of in 30 days time of the 30-day period, I think it was given. I've forgotten actually which, let me check. It could even be in the first lecture. There's a very simple formula for you to do that. Maybe in the second one. Anyway, you guys have it. Okay. Here you go. Yeah, forward volatility. In lecture 5, page 42, you will find that formula. I could just go there. And show you where it is. Lecture 5, page 42. Oh, it's here. Okay? This is the formula that we're referring to. So you just plug that right in, it starts talking about this from page 42, but the formula is on page 43. So you just plug that right in, and the answer is, oh, I don't need this one. Oops. The answer is C, actually. Okay, 11.3. I won't. Why don't you go home and practice on that? Okay, I won't go through this question here. Now, question 3. 4, 5, 6, 7, 8. Okay, now let's see if I can run through all the questions of this set first. So question C, with the share price at 100, I am long a call at 95 and I'm short a put at 105. My habit is I like to try and draw a diagram. So I'm long the call and I'm short the put. If I'm long the call at 95, and I have properly delta hedged my position, and afterwards I lower my volatility. Okay? So I'm long the call at 95 and it's now at 100, and I'm short a put at 105. So when you add the two together, you probably have something like this. That's the final result. Okay. So long call and short the put. Now I have properly delta hedged my position, and afterwards I lower my volatility. So the first thing to recognize is just precisely what I was telling you earlier in the previous data set. The previous question set on the last page, that first of all, let me go back there. When you are when your payoff function is sinking or rising, okay, what happens to your gamma parameter and your delta parameter when you are in the money or out of the money? Okay, now that's the first thing. The second thing is, under what circumstance will you get your payoff function to start sinking? Well, when time passes, it will happen, okay? Or when you decide to suddenly reprice with a different volatility input, that can also happen. And that is precisely what this question is referring to. So let's take a look at that, okay? So you are long a call at 95, and you are short a put. So you're actually long a call at 95. Now this one is in the money. That's the first thing to recognize. And you are short a put at 105, This one is also in the money. Okay, now it doesn't matter whether you are long or short. By definition, the option itself has value, or someone can claim on that, and you have properly delta hedged your position, and then you lower your volatility. Okay. The way to look at it is like this. So first of all, let's do a before and after. Okay, so before, for the 95 call, now this one is in the money. So let's say the delta is somewhere around 52. Okay, and when you are long the call, you are long delta, so this will be a plus sign. Okay, now if you are long the put, now this put is also in the money, so it would also have a delta somewhere around 50. Let's just say 52. Okay, but if you are put, if you are long a put, it will be a negative delta, but because you are short the put, the delta would be positive. Okay, so in other words, you are long delta, and you can really see that by looking at the end result. The end result is, what do you want if you have a payoff like this? You want the market to go up. That's it. Okay, at all times you want the market to go up, so you must be long delta. Okay, now that's before. Now what happens after? So let's say you hedge your delta properly by selling shares 104. Okay, so now you are delta neutral. Okay, now afterwards you lower your volatility, so your payoff curves will now be sinking like this. And for in the money options, your call delta would be slightly higher. Okay, so let's just say 55. Okay, and so will your put delta. It will be like minus 55. But as I said, because you are short, you got to flip that around. Okay, and your hedge hasn't changed. So this is your hedge, your delta hedge. So as a result, here the total is 0, as it should be. Okay, but now what happens is you have a little bit of delta slippage here. So you are delta long as a result. So B is the right answer. Everyone is okay with that? If not, if you go back and you listen carefully to the way I've analyzed this, it should be all right. I do recommend that if you were to go to YouTube, and if you want to check out those videos, at the very minimum, please look at the session today, and also for the session on November 17, look at the second one, this one, because this one is where I also covered all the questions in set 1. Okay, at the very least, look at that one. I see that it's got 17 views out of a class of 40. So either you already know it, or you think you know it, or you don't know it but you don't have time, or you don't know it and you don't intend to know it. Okay, I hope it's not the last one, because if it is, I don't need to make these videos. I think it's no point. Okay. Now for question 4. With a share price of 100, I have the following position. So I'm long two puts at 95, so these are out of the money, and I'm short one put at 105. All right. Now, first of all, so these are okay. So the share price is 100. So what you have are options that are symmetric, plus or minus 5% on the strike. And I recall that gamma diagram. So you can see that there's a pattern. We seem to be always going back to that wonderful, useful diagram. You need to, for this question, you need to make use of the diagram in the middle again. Okay. And the way to do this is, so first of all, the options are the same tenor, and well, this graph can represent, so the y-axis would be gamma, and this will be the strike. So let's say 100, and then 105 would be here. Now, for options that are near the money and approximately symmetric, their gammas are roughly equal. So if you are long two lots of gamma, long two lots of option, and you are short one, so I will bet that you must be gamma long, because you have two long options and one short option, and one option, the gammas would be approximately equal. So the answer has to be A or B. Okay, and because you are long. And the other consideration is for the put, so you are long an option, you are long two options that are slightly out of the money, let's say somewhere here, okay? Now the distance here, let's call it x1, and this is slightly out of the money, okay? Now for the other option, the other put is in the money, you are short that one, okay? So this will be the out of the money. I call that X2. Now these are, again, they are time value, or sometimes called optionality, okay? Now the optionality of this one and this one would be approximately equal. But because I'm long two lots of these and I'm short one lots of that, I should also be Vega long, because I have two lots of time value here, and I only sell one lot of time value there. Okay, so A is the right answer. Okay. Now for question 5. So the share price is 100, and you are long a call at 95 and long a put at 95. So you are long this, V for victory, okay? You are long a straddle. And at the moment, the call is in the money, because the so you might be somewhere here. The share price is 100. Okay. Now you are delta hedged. You are long gamma, and you are long Vega. Why don't I ask you to do this question? I really like this question. So why don't you just spend a little time? Just spend 2 minutes and try to figure out what is the answer to this question. So the share price drops by $2.50. The volatility rises 2 points. I'll give you 3 minutes to do this. Okay, starting now. All right. Have you actually gone through this? I'm so sorry, I should have asked you. Have you gone through this question before? You have? So why is the answer D? Can someone tell me? Why do you earn more than 26.25? Yeah. All right. I challenge someone to tell me why the answer. Okay, now for the gamma revenue, it's a half times gamma. What's gamma? 2 times the square of $2.50. So that is 625. So that is the gamma revenue. You get to keep that. And for the volatility, for the Vega, it's gone up 2 points times 10. So that's 20. Okay, so you also get to keep that. That's your I don't want to call it Vega revenue, Vega gain. Okay, so total you make 26.25. Thank you very much. Why is C not the right answer?
Gamma and Vega is not constant. Gamma and Vega are not constant.
Gamma and Vega are not constant. It's true, but it says ignore theta for now, but we do not keep gamma and Vega constant. Well, in that case, shouldn't you be making less? Because the price now drops. Actually, if it drops to 97.50, so let's say 100 was here, okay, and you go in this direction, actually the gamma will increase. So if you were to use just the old gamma, okay, it's probably not correct. The closer you are to being at the money, the higher the gamma value would be. Okay, so if the gamma is higher, then of course you should. This is the minimum you will earn. Okay, but the key to it is that this gamma here will change. Okay. I want to tell you also another thing which is quite interesting about straddles, which you may not have thought about. If you are long a straddle, so let's change the situation a little bit. And this is actually how you can see that when you are trading options in practice, some of the things that you learn, they really need to be adjusted. So let's say the spot price is 100 and you are long a call. So spot is 100 and you are long a call at 100 and you are long a put at 100. Now, what do you think would be the approximate value of your delta if you are long a call at 100, just approximate, and you are long a put at 100? And the spot price is 100. It would be approximately 0. Okay? And likewise, if you are short the call and short the put, because Where's my option pricer? It's gone. I thought I had it. Because you can see that I'll try to make it as close to 50 as possible. Okay, so 90 days, cut the interest rate, cut the dividend. So if you are long the call, you have a delta which is around a half, and if you are long the put, you also have a delta which is around minus a half. So if you're long both of them, you actually end up having a delta which is very close to zero. Now, what is the point I'm trying to make here? The point I'm trying to make is you are actually running substantial option positions by being long this one and long this one, or short the call and short the put, okay? And from your option book, in total, it looks like you don't have any delta exposure. And you go home and you sleep well and you say, oh yeah, I don't have much exposure to the market. Well, you do. You have a lot. It's just that it's going to swing this way or that, okay? Which is good for you. But if you are the other way around, okay? Suddenly, one day you wake up and Donald Trump has won the election and the market suddenly starts going that way, and you get called by your boss and say, you know, you're losing a lot of money, and you say, no, I'm not, I don't have any delta, okay? You know what I'm saying? Yeah? So now, this is only with two options. Imagine if you have like 2,000 options, okay? And they're all mixed together with all kinds of Greeks flying everywhere. Sometimes you can't tell. And that's when you probably have to run some kind of simulation. So you cannot entirely trust your delta. And you have to simulate the prices and see how your book value actually changes. Okay? Are you with me there? Yeah? You understand? Okay. If you go for a job interview, you start talking about that, people will be impressed. If you understand what I just said to you. Now, question 6. With the share price at 50, my option position, which is not delta hedge yet, has the following Greeks. Today is October the 1st. I'm long gamma, short vega, short delta. This is my book. So what positions could I possibly be running? A, B, C, and D. Now, the best way to analyze something like this is just to lay them all out. So for choice A and B, and C and D, let's try and figure out what is happening to the gamma. Okay. For choice A, I'm long option. I don't even care what kind of option, so I must be long gamma. Okay. Now for B, I'm long a call, 51 call, so that is out of the money, and I'm short a 51 put, which is in the money. Now, for B, if this was an October put, then I think the gamma of the call and gamma of the put will be roughly equal. Okay. Now, because it's a November put, the gamma would be different. In fact, the gamma of the November put, so gamma of the put November would be slightly less than the gamma of the call for October, because a shorter term option has a higher gamma than a longer term, and they are approximately symmetric versus the spot price. Again, for the 35 time, it's all to do with this diagram here. Okay, so understand these three charts and you can do a lot of questions. Yes, Simon.
How can I see where the break points to grow?
Very good question. How can you see the break-even points? I think generally, Timon, when options are 5% in or out of the money, okay, that's when they cross over. So you can think of it that way. In fact, if in doubt, look at the table, the numerical table up there. When it's 5% either side of the spot price, okay, that's when they cross over. Can you see that? Yeah, so you can make that assumption. I think with a lot of the questions that we will ask you, they will either be at the money, or let's say plus or minus 5%, or they will be really, really wide, wide apart. Yeah. Okay? Yeah. Thank you for that question. Thank you for that question. Now, so for B, I'm now comparing, so for B, the gamma of the November option is less than the gamma of the October option, but I am long the October option, so I must be also long gamma. So I'm long the one with a higher gamma. So now here I am short the October, and I am long the November. So I'm short the short term and I'm long the long term. So this one would have a higher gamma than this one, and I am short, so I will be short gamma here. And for the last one, I will be long gamma because I'm long a shorter option with a higher gamma. Okay, so already I can throw out C as the answer. Now, and then you can look at Vega. Now that's an easy one. If I'm long and long, I have to be long. If I'm long a call, which is $1, let's say $1 away from the money, positive or negative, okay? And then I'm short another one, but this one is a longer term. Now a longer term option will have more Vega sensitivity. And if I'm short this one, so this one would have a higher Vega. Let me just write that down here. Okay, so maybe the long call at 51. So this one will have a Vega. So let's say the Vega was, let's just say 5, let's just say, okay, and then I'm short the put at 51. Now this one would have a higher Vega, let's just say 8. And so because I'm short, this one will be negative. So overall, I am also short Vega. Okay? And you can just keep going like this. This one is long because I'm long the longer term option, I'm short the shorter term. Here I am short the longer term, I'm long the shorter term, so it has to be minus. And you can do the same thing for delta. Again, you make use of the two things. Okay, the first thing is the symmetry between whether you are in the money or out of the money, and also the relationship between longer term options and shorter term options as far as the delta is concerned. Okay, let me give you an example. So for A, for answer A, you are talking about an out of the money call. So let's just say that one has a delta of around 49. And you are also long, and in the money put. Now in the money put would have a delta of around, let's say 53. Okay, it's definitely above 50, and out of the money call is definitely below 50. So on a net basis, you will be short delta here. So short delta. Now A cannot be the right answer because you are long gamma, long Vega, and short delta, but you should be short Vega. And you can actually do it for B. I'll leave it, you can go home and it's actually a good exercise for you, but I will at least tell you. So of all the combinations, D is the only one that would work exactly. Okay? Now for question 7, do you guys have to go anywhere after 12:30? All right, if you have an appointment and if you need to leave, feel free to do so. I really don't mind, but I'm going to cover questions 7 and 8, and I will briefly just go over the remaining material. Okay. Now, question 7. So we talk about skews, which is how the market often price out of the money put options. Is let's say the market was the spot price was here, and if you're pricing out of the money puts, so this is the implied volatility. So out of the money put vols would be higher than out of the money call vols. Okay, and you have a position as follows, where you are long the put. So the spot price is 100, and you are long the put at 95. So you have this, and you are short the call at 105, like this. Now this is a classic risk reversal for trading from the short side. If you are long a risk reversal, normally you trade like this, but you can do it the other way around, and you are doing that right now. Okay, this is when you are well, you can long a call and short a call. This is just another way to manufacture a risk reversal. Okay. So here, for the one at the top, here you are short the put, here you're long the call. Here is different. Here you're long the put, and you are short the call. Okay. There's a variety of ways to manufacture these things, but I'm just doing it the way they are describing it. Okay. So they're asking you, are you gamma flat and paying theta, or are you gamma flat and receiving theta, or gamma flat and you don't have to pay or receive anything? Now, if you're gamma flat and paying theta, that just means from one day to the next, if the market remains exactly the same, you will actually lose money, or the value of your position will drop. Okay. The only thing you need to think about is that theta, which is the ex ante estimation of market movement, is equal to a half gamma sigma s all squared. Okay. Now, for options that are approximately equally away from the money, $5 away from the money, the gamma should actually be quite similar. Okay, so the problem actually here is this parameter. So for your call theta, it will be a half times the call gamma times the call sigma, and for the theta of the put, it will be this. Okay. The problem here is we assume that these two are roughly equal. Okay, so you are gamma. In fact, gamma flat is a bit silly because you don't. All the answers says you are gamma flat, and you are. Okay. The problem is the sigma for the put is likely to be noticeably higher than the sigma of the call. So as a result, the theta of the put is higher than the theta of the call. Now, you actually bought the put, so this one is going to decay faster. So as a result, you will be paying theta. Pay theta means, when time passes and nothing happens, you are not really too happy about that. Okay, and that is the case here. Okay. Now let me get on to question 8. Okay. Sorry that we go quite fast. Difficult one. No, it's not. It's not difficult. Okay. Okay. Now, we have the following position with share price at 95. So you're long a put, which is at the money, and you are short a call, which is out of the money. All right. So what does that look like? So you're long a put at the money, 95, and then you are short a call at 105, which is actually quite far away from the money. Now it's almost like 10%. Okay, and you raise your volatility for all strikes. What happens to your vega? Now, there is another distant Greek relative in the Greek family known as Vana. And this one is, again, is a second derivative. This is actually d vega d vol. Okay? What is going on here? This is saying what happens to my vega when volatility itself changes. In other words, let me show you. Now, that you see, when you are pricing the calls and the put options here, there's a vega here, right? 0.198. You can see that. If I change nothing except the volatility, which was 25, if I now change it to 26, and if I hit calculate, you will see that the vega values are going to change. 0.198. Oh, they don't change very much. Okay, let's pump that up to 30. Okay, then they will change. They don't change. You know why? I'll tell you why. Because this option is at the money. That's exactly the point I want to make to you. Now, let's say you have, so the underlying price is now 120. Okay, now look at the call. I'm going to start at a vol of 20. Okay? So you have a call option which is deeply out of the money and priced at a vol of 20. Now, if I change that to, and the vega is 0.04. The vega is 0.04. You can see that, right? Now, I'm going to change the volatility to 21. Okay? Watch what happens to the call vega. It's now 0.047. Now, you might think, yeah, well, so what? It is not. To change from 0.04 to 0.047 is at almost a 20% change, isn't it? Isn't it? Yeah? Now, just now I showed you, and then it's a 20% change. Now, if your option is at the money, okay, you don't really get a lot of change to vega. So now it's 198, and even if I pump it up to 30, it doesn't change very much. Okay, this is trying to measure the change of vega itself, whereas if I start from 20, but this option was seriously out of the money, so the vega, as I said, was 0.04. If I now change the volatility to 30, it's going to really jump from 0.04. Now, it's actually jumped 2.5 times from 0.04 to 0.1. Okay? So my message to you is this. For vega of at the money option is not sensitive to change of implied vol or sigma, okay, IV, okay, but the vega of out of the money options is sensitive to the change of the implied vol. Are you with me there? Yeah? Now, I'll tell you what this means, okay? First of all, if this is the spot price, let's just use 100, okay? And I'm going to plot vega on the y-axis. Now, so this is vega. Now, it is true that when options are at the money, vega is maximum. It's the highest. it's another way of saying when you have an option, the maximum amount of optionality is actually this point. Well, of course it is, because that's when it's thicker than these areas. However, the vega here is maximum, but it doesn't change. Okay, now here, vega is very small, but it changes when implied vol changes. Okay, that's the message that I want to share with you. Okay, so this question is not about vega itself, but how vega will change when volatility changes. And you ask me, well, what do you mean? It's actually trying to measure how this 0.102 parameter, how this change when vega is changing, let's say from 30 to 31, okay? It jumps around quite a lot. Let's say to 35. So vega now goes from 0.107 to 0.125, whereas if this option was at the money, vega is huge, okay? But it does not react. It hardly reacts to volatility. So 35, or let's say even 40, okay? Vega doesn't change. And this interesting characteristic is actually captured by this Vana parameter. Okay, so it's a second derivative. Okay? Now, let me just go to the just go very quickly to the lecture slides. Now, what I was hoping to do today was to go through. What I wanted to do today was to at least go through question sets 2 and 3. And I'm now going to very quickly give you a checklist of the things that I think you need to know for this course. Some of them we have covered. Average delta, put call parity, straddles, forward trading, index spreads, calendar spreads. We've done all of those. Delta, gamma, theta, vega, skews, forward vol, volatility curve fitting. I haven't done that with you. Leveraged ETF, I did touch on that. Rho, we talked about that last time. Now, early exercise and dispersion trading are possibly the two remaining topics. Together with that set of questions, the last set of questions. And I think I would like to cover that in one of three ways. Either we come back here within the next 3 days, or we do some kind of web conference, and I have the tools to do that, or I just publish the answers to those questions in a video format, and then you can, okay, let's be real democratic here, okay? Now, for this next question, okay? Next question is this. Next question is, in the next 3 days, would you prefer to come back to a classroom, or would you prefer to do some kind of a web conference, or would you prefer that I videotape a set of responses to those questions plus the questions that you have asked me, which are in that Google document, and I thank you for that. Okay, so I will A or B or C. Okay, I'll give you 1 minute. Okay, you don't need to think about that. Okay? So please speak your mind. Oh, D, do nothing. Okay, I can do that too, if you want. What? I suppose E is do everything. Don't choose that, please. You're going to kill me. Okay. It's a joke, okay? I'm not going to take either D or E as answers, okay? Okay, 20 seconds. Ten seconds. Please place your bets. Okay. Well, someone really did pick D. Do nothing. All right. Well, you're in a minority. I'm sorry. So it looks like people either favor well, C mostly. Okay. Well, I will do that. I want to thank you. Let me just show you the slides today very quickly. So these will be online sometime today. So you should know all of these. This slide you haven't seen before, okay? So it's new. It's just using a table format to relate the graph before, okay? This one also you haven't seen, okay? Don't memorize these tables, try to understand them. This is the forward variance formula. These rules I have told you about already. Early exercise, we talked about that last time. I will go through those questions. American call exercise, row. I explained how these graphs actually are, why they are the shape they are, and why row behaves in this manner. And now time decay, now these slides we haven't seen, but it's just showing you how an option price can evolve over time when nothing changes, okay? Likewise for a straddle. So it looks like that. Dispersion trading is really nothing more than sometimes called volatility arbitrage or index volatility arbitrage. It's about trading an index versus the or options on the index versus options on the individual stocks within the basket. I might say a bit more about this maybe in the video. There were some other questions. If you can answer this question, I think you are doing well. If you know the answer, okay. So other than that, this is what we have done so far. So this was session 1. And then session 2, we talked mostly about the Greeks and the forward vol, and then the rules. And last time we went into put call parity, and then the question set. And then today we actually covered quite a lot. Now, once again, I'm sorry if this treatment is far from ideal. I have done with you in 2 weeks what should normally take 10 weeks. So if you can handle that, you really are you are doing well. Hold on a second. Hello? Hey. Sorry, that was Tracy. I had to answer the call. Right. So I want to thank you for your attention, and oh, hold on a second. Let me just say